Thanks everybody for taking a few moments of your day to spend with me, talk about DB2 SQL. This is actually part 3 of a once a month thing we've been doing. I think this will be the last part for now. And if you missed the first 2 parts, you can go out to our website and check out the replays are available there. So that is at themisinc.com/webinars, and I'll show that to you in just a second, or I'll have a page with a link on it here. Also, if you would like to get a copy of today's presentation, it is also available at themisinc.com/webinars. My email address is on the board here, dsimpson@themisinc.com. You can feel free to send questions to me after we're done here today, and I try and get to every one of those that I get after these things. There's also a question box in the webinar that you can put some things in. I will not necessarily get to all of those during the webinar, but if you put something in there, I will try and respond to you personally afterwards if we don't get to it. You can also follow us on Twitter at Themis Training. That's our fairly new Twitter account. So follow us on social media to stay up to date with what's going on with me and my company Themis. So this webinar is sponsored, brought to you by Themis Training, Themis Education, the company I work for. So just a quick word from the sponsor, and down there at the bottom here, you can go out there right now, themisinc.com/webinars, to get a copy of today's presentation in PDF format. That is out there right now. So if you want to go right now and download that, themisinc.com/webinars. A little bit later this week, maybe later today, will be the replay of today's webinar. And already out there you can find replays of lots of webinars we've been doing over about the past 1.5 or 2 years. So let's actually take a look at what's out there right now. You can see the download for my slides for today's presentation. That's the SQL for the 21st Century Part 3. And you see the replays of a lot of previous webinars. I'll call your attention also to some upcoming webinars. If you have interest in DB2, which I would assume you do since you're here today, we got several coming up that will be of interest to you, or a couple anyway. Linda Clausen, one in June and one in August that she'll be doing, one on the enhanced explain tables for DB211. So all the extra explain tables beyond the plan table, she'll be talking about all those, what's in them, and how we can get some interesting information out of there. And then she will be doing one all the way out in August on minimizing trips to DB2. So that'll be more of an application performance by how you code your SQL and where you place your SQL within programs for maximum performance. Some other non-DB2 topics we also have coming up. Next week, Tom Dunlap, who has been doing CICS all the way back since it was invented, we'll be doing a webinar on CICS storage violations. That's next week. If you are an Oracle person or know Oracle people, John Mullins, a few weeks later, we'll be doing one on Oracle 12c PL SQL new features that are available in the latest release of Oracle. So lots of stuff out there. I'd encourage you to take advantage of kind of some of these little free pieces of the training that we do. So that is at the website again, themisinc.com/webinars. It doesn't matter how many times I say this. I still seem to get several emails, every one of these I do. If you would like a copy of the slides from today's presentation, please go out to the website and get them there. Okay, so I'll get a few emails about that, I would imagine, a little later. And I will reply to all of those that you can get them at themisinc.com/webinars. And they're out there right now. Again, a little later will be also the replay from this webinar as well. So Themis got a really great DB2 curriculum. I feel like we got some of the best instructors in the industry, and one of the best curriculum, most complete curriculums in the industry related to DB2. Many of you have heard or seen Linda Clausen in the past. She is a former IBM Gold consultant and has been frequent speaker at conferences like iDoug, going back a lot of years. Tony Andrews, also one of our instructors. A lot of you have seen him at iDoug and other local user groups as well. So we got a great bunch of people that maintain our DB2 curriculum that we own and keep up to date. And we got some great instructors who got a lot of real practical, real-world experience with all different angles of DB2. So we do training as our primary line of business. We can either come to your place if you have enough people, to fill up a class on site, or we do a lot of public training at various locations around the country, mostly in North America, for the public schedule. But one of the ways we're reaching out, well beyond that with our public schedule is with distance learning or virtual training. We can offer that to just about anyone in the world. So you can take a look at that on our website as well, themisinc.com. The distance learning thing is, a live class, kind of like what we're doing right now, only it just goes on for several days. So we can deliver any of our courses in that venue, and so we can assemble for, say, a class like on DB2 installation, which is hard to get a whole group of people together in one place that all need that at the same time, but we can kind of offer it nation or worldwide via distance learning. Okay, so that's a little bit about us. One class I want to feature in particular today, we have an upcoming DB2 for ZOS SQL optimization, performance, and tuning class on May 16th. That is offered via distance learning. If you download the slides for this presentation, those two things are hyperlinked there. You can see a description of that class and a link to the registration for the May 16th offering. That'll be me teaching. So if you kind of like what you hear today and you need like 4 more days of me, you can feel free to sign up for that or share it with your friends who you think it might be helpful for. So that's, again, optimization, performance, and tuning. We focus on SQL in that class more than the system side of tuning. We're looking for ways to write SQL that'll improve performance, ways to deal with things like statistics and analysis of predicates, all of that to help you get better performing SQL. So that's coming up on May 16th. We got a few seats left in that for our distance learning. Again, it'll be kind of like the venue you see now, only with hands-on and a little more interaction from the attendees. All right, if you've been on the first couple of parts of this, you've already seen this picture. This is me, been doing this for a while. Started working with DB2 in 1993 as an application programmer, spent some time as a DBA in a couple really large environments that were kind of moving their whole business to DB2 when I got there both times, and where those lines of business are still very heavily dependent on DB2, and particularly DB2 on ZOS. I also have done work on DB2 LUW, especially application stuff with SQL. And the SQL that you're going to see today is, for the most part, cross-platform across the DB2 family. There are a couple of things that only work on either mainframe or LUW, and I'll try and point those out as we get to them. I think it's actually written on the slides. Okay, so that's kind of where we're going. And again, if you have questions as we go along, you can put them in the box. So would love to hear from you as we move on. The first 2 parts of this webinar, I focused on things, SQL enhancements that were largely related to the select statement. And so what I decided to do today to kind of wrap up this little mini-series we've been doing is spend one webinar focused on SQL enhancements in the last few releases that deal with data modification. And I actually think that's important. That's kind of a forgotten, sometimes forgotten anyway, angle of DB2 performance. We spend a lot of time tuning queries and somewhat less time looking at what we can do with insert, update, and delete to not only make it function the way we want, but also to help improve performance. So that is what we're going to focus on here. I always go back to when I talk about this kind of topic, the one application that I worked on at one of the places where I was a DBA, we actually had a series of, it was 8 or 9 tables that were written to hundreds of millions of times a day, if you put them all together, and were queried with select statements really, really infrequently, like maybe 10 or 12 times a day. So you've got 100 million inserts a day going on and like a dozen or 2 queries. The focus of our tuning efforts was completely on insert performance. Right. So we do have these applications that are, I heard Roger Miller years ago call these like write once, read never. We used to have write once, read many kind of performance. So, if you're going to write rows occasionally and then query them all day long, you're going to be focused on what you can do with select and how you can tune select. But very often now we run into these applications that we're squirreling away data that we never actually query or very seldom actually query. And so the focus will be on, what can we do with insert, update, delete to make that more functional and perform better. So that's what I'm kind of focusing on in this presentation, the things that are in the last few releases that kind of relate to data modification. Okay. And the first one of those that I think I want to touch on is the merge statement. So this came back in about DB2 version 9. It is available both on DB2 LUW and ZOS with a little bit of functionality that is missing from both sides of that equation, and we'll talk about that in just a second. The merge statement is sometimes referred to as an upsert, right? So I'm either going to insert or update data, and I don't know, right? When I write the statement, I might do an insert, I might do an update, depending on whether the row or rows that I'm talking about are already present. And so that's what we're going to be focusing on in this section of the presentation. So merge statement kind of generically looks something like this. In this case, I have a table called item, and I have a set of, the item table here has 2 columns on it, so it's pretty straightforward. You'll find merge can actually get quite long, the statement, because you're referencing all the same columns over and over and over again. In order to get the example to fit on the slide, I did this one with only 2 columns. So I have an item number, which would probably be the key to that table, and an item name. So I have a row, right, an item number and name that I want to either put on the table if it's not already there, or if it is already there, I would like to update, in this case, the item name. So in other words, if item number is already there, I want to change its name to widget. If item number 1 is not already there, then I'm going to insert it with a name of widget. And so you can see syntactically how this works. It's a little bit complicated, but we break it down into the pieces. It's not bad. Merging into the item table, we're going to call that I. We're giving a correlation ID. Using, and here I'm saying what are the values for the row that I want to merge. And so I'm saying, the number 1, item number is 1, and the item name is widget. And I'm going to call that row that I'm working on inserting or updating new item, and I'm listing its column names there. So that new item, you can think of it like a little 1-row table that I'm making on the fly here that has the row, or in this case row, or perhaps rows that I'm talking about merging into this table. The next thing, the 4th line there, is an on clause, and we're used to seeing on clauses in things like joins. And that actually should clue you into what is really going on here. We are actually going to be doing a join with this statement. What we're going to have is 2 tables. We're going to have this new item table that has my new little row, and we're going to have the item table, which is kind of the base table with all the, the real table with all the rows in it. And I'm going to be joining my new table to the base table. And you get to specify here with an on clause how you're going to decide whether or not that row is already there. Right? On I.item number equals new item.item number. If the item number 1, is already there, then we have a match. Right? If that on clause evaluates false, meaning there is no item number 1 on the base table, then we do not have a match. And then you simply have two clauses, right? When I have a match, what do I do? When I don't have a match, what do I do? These update and insert statements you see within those matched and non-matched clauses are a little bit sparse. They do not have, they're not complete insert or update statements. So if you look at that update statement, update set item name equal new item dot item name, you know, you can see some things that are kind of typically present in an update statement that are not there, right? Update normally has a table name. Update normally has a where clause. And both of those things are missing because this is not a normal update statement. It's not a complete update statement. The only table I can update here is the item table. Right? So I'm updating the table that I'm merging into. And I'm setting the item name equal to new item dot item name. Remember, that's my little temporary table sort of that has the row in it. So whatever the item name came in, that's what I'm going to specify there. And I don't have a where clause. Well, I'm not updating all the rows of this table. I'm actually only updating the ones that matched, ones that met the conditions of my on clause there. Right. The same way on that insert, when I don't have a match, I'm going to do an insert into the table. And again, I'm missing a table name there. Right? So it's not a fully defined insert. The only table I can operate on there is the item table. And it's a good idea, just like always, to list the column names for an insert so that you control actually what is going where. So this is kind of an upsert. It's all a single statement. Right? I will either have updated a row or inserted a row, and it will depend on the value of item number. And this is for a single row, right? One single row, whether it's matched or not. So I used to kind of tout this as a universally good thing. If you have a process that is sometimes inserting and sometimes updating, what you would have had to do in the past, well, you can get a good argument going among developers about what's the best way to do that. Right? The program, should it select the row and see if it's there, and then in your program with logic say branch to an insert or an update? Back in the day, I used to see stored procedures written for that purpose, where you send in the row and let the stored procedure figure it out. You could blindly try the update, and if you get a an SQL 100, then you fail back to an insert. You could blindly try the insert, and if you get a duplicate row, then go fail over to an update. All right, so there's lots of ways to do that, but they all involve multiple statements. Right, so here we're doing it in one statement, one trip to DB2. So you may hear Linda Clausen talk about this all the way out in August when she talks about minimizing trips to DB2. This is kind of one of the techniques we can use to do that. We're only going to go to DB2 once. The potential downside here is that join. Right, because every merge statement you run is going to do a join between the little table you make and the base table. So it is a join going on right there, just as if you coded it in a select. All right, and joins are joins have an access path. Joins are a little bit tricky, performance-wise. So you want to take that into account when you're using this technique. It's probably simpler to code than branching all over the place. But if you really have a situation where you've got a bunch of rows you're processing and 90% of them need to be updated and 10% of them need to be inserted, that update statement is going to perform better than this merge for that purpose. Likewise, if I have 90% inserts and 10% updates, then an insert's going to perform better than this merge. And then you take the handful of failures you get and go do the other thing. If you're really about 50-50 or you don't know, then this is a good technique to, it's a good tool to have in your toolbox to be able to do that. So those literals, I'm doing this with literals, but you could put host variables or parameter markers where you have the number 1 and the widget. And that works just fine as well. Okay, so that's kind of the base merge. And we're going to see a few other things that we can do with this. Now, one of the things that we can do in LUW. So I've got this marked, I think, LUW only. Yeah, up at the title there. In LUW, you can also merge two tables with a select statement or with a sub-select in there. So in this case, instead of listing values in that using clause, I am listing a select statement. And if you're familiar with Oracle, this is the way Oracle deals with the merge. Oracle doesn't support merge the other way, or at least it didn't last time I checked. They do it this way. So if I have like a transaction table full of rows that came in from the transactions today, and I want to merge this into my big table where the historical data is, this is a great way to do it rather than kind of go row by row. And so my using clause is now a subselect. That subselect could identify 0 or more rows. So in this case, you see I'm merging into my dept table, but I'm selecting from a different dept table, and I'm calling that different dept table OD, right? Other department table, I suppose. And I'm matching where on od.depno or d.depno, that's my base table, equals od.depno. So department number is the key there. If I had a multi-column key, then I would have, you know, a bunch of anding together in that on clause. Looks like when I get a match, I'm going to update and change all of the non-key columns to the new value. When I don't get a match, I'm going to do an insert, and just like on the previous example, you know, let's list the values, the columns and values out of that OD subselect. All right, so this is a way that's currently only supported on LUW, and LUW, by the way, supports the other way as well. So if you're on LUW, you can use either technique. If you're on ZOS, we can only list individual values. Now, one thing I don't have a slide on in here, and if you take kind of our full class that covers this stuff, we talk about this a little bit. DB2 ZOS does support multi-row merge in the same way it supports multi-row insert. So that's something Linda Clausen may get into in August when she's talking about minimizing trips to DB2. So if you're working in COBOL, for example, you can load up arrays with, you know, 100 rows and then do a merge using host variable arrays. And it'll be similar to this, where you kind of have a whole table full of data now, rather than just a single value or single set of values for a row. So that exists only on ZOS, but not on LUW. So this is a feature that has pieces hanging off on both sides, some that work on ZOS, some that work on LUW. But the base merge, the first example we looked at, will work on both platforms. All right, we're going to come back to merge in a little bit, because one of the questions that I get asked a lot with merge is, how do I know what I did? And my original answer to this question was, you know, I mean, what I mean by that is, did I do an insert or did I do an update? And my original answer to that question was always, well, why do you care, right? The row is there the way you want it now. Why do you care? And the answer I get back to that question most often is, well, I got counters, right? I'm running a batch program, and I've got to count how many updates and how many inserts I did, and display it on a report at the end. So there is a way to do that. It's a little bit manufactured, but we'll see it in just a moment. We got a couple other features we got to talk about before we get there. Okay, but there's that. Well, I should start out by saying, I guess there's no kind of implicit DB2 way to tell whether you did an insert or an update. In other words, there's nothing in SQLCA that'll tell you how many inserts versus updates you did. You will get in the SQLCA SQL ARD occurrence 3, which, if you're familiar with that, when you do an update, just a regular update, it tells you how many rows you updated, or you do a delete, it tells you how many rows you deleted. This one will tell you how many rows you merged, but it doesn't differentiate between an insert or an update. All right, so nothing in the kind of the generic instrumentation you get back from DB2 that tells you how many updates versus inserts you did. We kind of have to manufacture that, which we'll see shortly. All right, another thing that is in sort of recent releases of DB2, we're going back a few releases, I think version 8, is sequences and identities. So the sequences and identities are objects in DB2 that help us assign primary key values. And there's some conventional ways to use these and some kind of non-conventional ways, or unconventional ways, I should say. And we'll talk about a few examples of each. Okay? So a sequence is nothing more than an object inside DB2 that hands out numbers. Right? And we usually use these for primary keys, right? So, you got a customer table. The primary key of customer table is customer number. And when I want to add a new customer, I need to know what the next customer number is that I should assign. And if my customer key is always increasing, in other words, I'm adding one or some increment to the last one that I used, then an identity or a sequence is a great way to handle this. The more simple of the two is the sequence. Identities are a little more complicated, but it's interesting that IBM gave us identities first. So we got identity columns one release prior to getting sequences. And because of some of the problems with identities, we have some knee-jerk reaction going back to sequences. We'll talk about that in just a second. But a sequence is just a simple object in DB2 the DBA creates, and then people writing applications will ask for numbers. Right? Give me another number. What's the next number? So it looks something like this. So this is what the DBA might run. I'm going to create a sequence, give it a name. This one's called cust key. Then I give it a data type. Any numeric data type, exact numeric data type, so no floating points or estimates. But exact data types, numerics, integer, small integer, big integer, decimal, any of those are valid. Right, so mine is an integer. It that gives you plus or minus 2.1 billion values, right? And then I got a bunch of modifiers on it. I'm going to start with, it looks like 100,000. So in other words, the first number the sequence will give out is the number 100,000. The maximum value is a couple orders of magnitude bigger than that. What is that, about 10 million? So in other words, we will never give out a number bigger than 10 million. So if your application has like kind of a maximum number that it can deal with, you can set its max value. By default, the max value will be the biggest number that the data type can support. So for an integer, that would be 2.1 billion. Well, if you're saying my application can't deal with keys that big, you can tell it where to stop. And what the behavior you're going to get when you stop is going to be totally determined by that last modifier down there, that last option that says no cycle. No cycle says if I ever run out of numbers, I'm out, and the sequence returns, I think it's a negative 395 when you ask for another one, meaning I've given away all my numbers I don't have anymore. If you say cycle, then we just wrap around to the beginning. We start at the beginning and give out a number again. That actually works really well. I've seen some applications use that where the sequence is only supplying part of the key. So in other words, you may be gluing another piece of the key onto the value for the sequence, and we kind of wrap around when we use them up. Okay, so if you kind of want DB2 to assign a round robin number between 1 and 10, to every transaction, you could say start with 1, max value 10, increment by 1, cycle, meaning when I give out the number 10, the next one I give out will be back to 1. Right. So you got a lot of flexibility with this object, and increment by, obviously, how many. Do I increment by 1, or am I incrementing by 10, or am I skipping numbers? You get to decide that as well. Caching is a little interesting. In this case, I'm saying cache 100. So the next value that DB2 should assign for a sequence is actually stored in the DB2 catalog table called sysIBM syssequences. And I think you'll see the next assigned value column in there. This caching says how often are we going to go to the DB2 catalog and bump up that number. In this case, I'm saying every 100. So I'm not going to update the catalog every time someone comes and asks for the next value for this sequence. I'm going to cache 100 values. So the first one of these I get, it's going to go out and bump up the number in the catalog by 100, and then it's just going to simply assign the next one out of memory until we've used 100. Then it'll go back and bump up the catalog number by 100 more. So we're not constantly updating the DB2 catalog, because that could be actually a performance problem. It also, we can get a lot of contention on the catalog. So you want that to be a fairly decent sized number for an active sequence. However, the bigger you make that number, kind of the more gaps you may have in the sequence, because when we bring DB2 down, we're going to lose all of the cached numbers that we never gave out. So in other words, if I create this sequence and I give away two numbers, 100,000 and 100,001, and then we bring DB2 down and bring DB2 back up, the next number it's going to give out is going to be 100,100. So we've skipped 98 values, right? Because they were in the cache when we brought DB2 down. Okay, so the more you cache, the more gaps you might have, but the more you cache, generally the better performance is going to be for a really active sequence. Okay. So let's see how we could use this in an application. Insert into my customer table now. I got a customer number, name, and location, just a fairly simple table in this case. And I have values for the three columns. And if I want to use the sequence to assign a number, I can say next value for, and then the name of the sequence. Okay, so I don't have to go get the number first. I can actually throw it straight in the insert statement. If you want to get the number first, you can always do that systeme1 thing, right? Select next value for cusKey from systeme1. The sequence doesn't actually care what you use the number for, right? So if it gives it out, it's not going to give it out again. No matter whether you use it for an insert or whether you select it and then throw it away, the sequence job is complete when it gives you the number. It doesn't care what you do with it. Okay. And then I got values for the other columns on the table as well. This solves a lot of problems. I had applications going back to like versions 5 and 6 that I worked on where we had an ever-increasing key. And the application was always doing that select max key plus 1 before it could assign the next key value. And what you had to hope was that the application wasn't active enough that two of us did that at the same time. We both got the same number. And then when we go to our insert, one of us is going to win, the other one's going to lose and have to go do it again, right? So this one, it will serialize. It gives these out in series, and no two people are going to get the same number unless you're cycling. Okay. All right. We're going to see how to find out, what I just did there in a minute. That's another good question that comes up, right? How do I know what number I put in there? Because I did that insert, it comes back SQL code 0, your insert worked. What key did I just assign? We'll see that in just a second. An identity column is a column on a table that actually has a sequence kind of physically tied to it. And I said, this is interesting because IBM gave us this first. We came out one release earlier than the sequence. I think this was version 7, the sequence was version 8. And even the thing that really soured a lot of DBAs on identity columns back in that time frame was for a while, they couldn't be altered. So the only way to change the next number that the identity column was going to assign was to actually drop the table, which, that's a little bit harsh. They've since given us the ability to alter these, so it makes DBA's life a little bit easier when you're using these. But an identity column is simply the sequence stuff tied to a particular column on the table. So instead of in the SQL assigning the next value for a sequence to customer number, I'm putting it right in the DDL for the table. So the DBA says the value for customer number is generated always. That means DB2 assigns it. You developer, you do not get to assign a value for this column. As identity, start with, increment by, cache, all of the same stuff that went on the sequence could go here. All right, I'm taking some defaults there just to fit it on the slide. But any of the sequence stuff could go here. Where are you going to start? How much are you going to increment by? How much are you going to cache? You could have a max value. Tell it whether or not to cycle. Same thing here. Okay. Now on this, when you do an insert, the way you're going to handle this is just not reference that column at all. So because it's generated always, you just insert the other values for the other columns, and DB2 supplies the value for the sequence or for the identity. We have the question comes up again then, well, how do I know what I just did? And there's a better way to do this now, but the first way that IBM came up with, we're going back to, when this stuff was first invented on, I think, version 7, they gave us a built-in function called identity Val Local. And you could go interrogate identity val local, and it will tell you what was the last value assigned by an identity column in your application. So this is by thread. In other words, you're not going to, so if I do an insert and then I wait 5 minutes, while I'm still connected to DB2 and other people are doing inserts, and I then select from identity val local, I'm going to get the last value that I was assigned. Doesn't matter if other values have been assigned subsequently. All right, so it's just a scalar function that'll give you back what was the last number that was given to you as an identity column or as an identity value. Again, I don't think this is the way I would do it now, but that is the original way that they told you that you could figure out what you just did. So quick chart to compare kind of difference between sequences and identities. Sequence is a standalone object. Identity is just a sequence tied to a particular column on a particular table. Okay, one-to-one relationship. Particularly, sequences are more helpful if you have several tables that have the same data type for their key, and you don't want to ever have a duplication between them. So the sequence can give out values for 10 different tables, right, and never have them duplicate, where an identity is only tied to a single column on a single table. Both of them can be altered now. Version 8 and above, the identity column, they would let you alter the next value. This was a problem occasionally if you were to load data, into the table, and then you needed to advance the next value that was going to be assigned by the identity. Prior to version 8, you couldn't do that. And that's getting to be a long time ago now, but this is, if you talk to DBAs who have been around a while, this may be one of the reasons why they have kind of a bad taste in their mouth from identity columns. You actually had to drop the table to change the next value assigned for the identity. As a practical matter, I think a lot of people have kind of gone towards sequences now instead of identities, just because they're a little more flexible. Your design is not physically tied to a particular table. You can let the application kind of manage it. Okay, so a little bit of a comparison between the two different types of objects. Now, in version 11, here's a fairly new enhancement to all of this. A sequence can now have an alias. This was a problem if you were trying to share a sequence across different schemas in the past. So if it was supplying values for two different tables that were not in the same schema, your alias actually had to live in one of the two schemas, still does. But then the other one, when you're using the other one, you would have to actually hard code the qualifier for the actual sequence object. Sequence objects, just like any other thing in DB2, like tables, have, they live in a schema. They have an owner or a qualifier. Okay, so now we can create an alias. So the first one, I'm just saying, user2.sequence1 is an alias of user1.sequence1. So if we interrogate a sequence called user2.sequence1, I'm really just getting the next value from user1.sequence1. All right. The second and third examples there are examples of public aliases. And if I create a public alias, that goes into the schema called syspublic, which you can either hard code or leave off when you create the alias. But that just means that really that sequence is valid in any schema. So that sequence would be shared across the entire, all schemas in the DB2 subsystem. Okay, so you wouldn't have to qualify it from anywhere. All right, it's a public alias. All right, so this came in version 11, solved problems that people were having when they were trying to share a sequence across schemas. That is very seamless now in version 11 with this simple little sequence object, or simple alias object on a sequence. All right, so now we're going to try and answer the question that came up in both of the last two sections. How do I know what I just did? If I use a sequence to assign a value for a column, how do I know what that was? Or if I do a merge, how do I know whether I did an insert or an update? Okay, so we have this concept beginning in version 8 and being enhanced in versions 9 and following of a select from another operation. The first one that came was in version 8, and this is the example you see here. I'm selecting from, well, what's that final table thing? Let's leave that alone for a minute. And then in parentheses, I have an insert statement. So here I'm inserting a new employee, got an employee number, his name's Cacavel, some of you may have heard of him, and I'm using the current date as the hire date. Right, so there are other columns on this employee table, but obviously we're taking defaults on a lot of them here. What I really want to know there is, what did I just put in hire date? Current date is a special register from DB2. Right, so DB2 supplies the value of current date. But if your application wants to know what that was, in the past you would have had to actually go back and interrogate the table with a select statement. So I think in a select from an insert, or any of these other things that we're about to talk about, the primary thing is that we're doing, or the thing to keep in mind, is the primary thing we're doing is the insert. Right? We want to insert a row to the table. I also just want to know what I did. Right? So a select from an insert says do the insert and select back some of what the rows that I just put on that, or some of the columns for the row that I just put on that table. So in this case, I'm saying give me the hire date. Well, what did I put in the hire date? Current date. This is really helpful for any time you are using values that you aren't supplying out of your program. Right? So current date, current timestamp, current user, or things like sequences and identities, which we'll see an example of in just a moment. Oops. Or now. How about that? Here I'm inserting into my customer table, customer number, name, and location, values. Well, next value for customer key is going to be the customer number, and then I have literal values for the other two. I'm here selecting customer number from final table and then wrapping the insert in parentheses. So I will actually get back from this statement the value that I put in customer number, whatever came out of the sequence. I don't think I'm showing an example here of doing the same thing with an identity insert. I am not. But you could do the same thing, and that's why I said that identity Val Local function that they gave us back all the way in version 7, I would not use it anymore because in subsequent releases we've gotten the ability to do this, where I can actually just select from the insert, and I get it in one step, one trip to DB2 instead of 2. And that's particularly important performance-wise if you are in a distributed kind of application like Java, WebSphere, anything like that, where a trip to DB2 means going across the network. So if we can do it in one trip instead of 2, that would be great. So I do this select from insert, and I get my customer number came back at 201. Right, so this kind of operation is like a select. So if you're in Java or C# or some distributed thing, you're going to have to get a result set back from this. Right, so it would be treated like a select, like a query, you wouldn't do this in an execute non-query kind of thing if you're in Java or C#. Even though the primary thing you're doing is not a query, you do get a result set back from it. In COBOL, for those of you who are COBOL programmers, you're going to have a select into here. You're going to have a place to put it. And if it could return multiple rows, this one can't, but you might have to have a cursor even. We'll talk about that in a minute. Right, so select from an insert. Now let's talk about that final table thing, I guess, for a moment. When I first saw this back in version 8 when it came out, people would ask about what the heck is that final table? I'd be like, I don't know, you got to have it. It's the name of the table we're selecting from, right? Which is not a real table. It's going to be the final table that results from this, the insert. When they implemented select from other things, then it started to make sense what that meant. So beginning in version 9, they allowed us to also do a select from a delete. And when I do that, instead of saying final table, I'm going to say old table. Okay. So here I'm deleting all the people whose job is clerk. And that ended up being about 6 rows. And I want to see who was it that I just deleted, right? Let me see those rows in my application that are now no longer there. This works great for purge processing, right? If you need to archive somehow the rows that you're deleting in your application, you can do it in one step. Give me back what I just deleted as a result set. Now again, if you're Java or C#, this is going to give you a result set. If you are COBOL, then this is going to have to be a cursor. Right, because you're going to get back multiple rows, or you could get back multiple rows from this operation. Really, the primary thing I'm doing is a delete, but I'm also going to see what I just deleted. Now here I'm going to say old table instead of final table. And the difference is final table is showing you the way rows look after the operation that you just did. Old table is showing you the way they look before. So if you're doing a select from an insert, it's always final table, right? There is no, what did these rows look like before I inserted them? Right? They weren't there. For select from a delete, there is no final table. In other words, there's no way the rows looked after you deleted them. They're already gone. I don't have an example here, but if you were to do a select from an update, then you can specify either old or final table. In other words, do I want to see the rows the way they look before I change them or after? Okay, so old table and final table are going to be both valid choices for a select from an update. But if it's a delete, it's always old table. If it's an insert, it's always final table. Okay. Now, the other question that came up earlier, what about a merge? How do I know what I just did with a merge? We can select from final table on a merge. And here's how we're going to do it. We're going to actually have one of these include columns. We're going to do a select from final table on a merge, and we're going to put an include column on the thing that I'm merging. So this include update indicator char1, you can think about that as a little fake column that I'm tacking onto the end of the item table. Right? It doesn't exist on the actual table, but I'm going to pretend that it does for purposes of this merge. And the rest of the merge, till I get down to toward the bottom, looks the same as what we saw earlier. In the update statement, though, I'm actually also then setting this update indicator to a U. And in the insert statement, I'm going to set the update indicator to an I. Oops. Now I can select from final table, and I can include that update indicator. And you will get back from this a result set again that has the item name you just were working on in this case, and either a U or an I, depending on whether or not I did an insert or an update. So now you can track with counters or however, whatever you need to do with this, whether or not you did inserts or updates. Okay. This is one of those examples you probably just have to stare at for a little while before it makes complete sense, but it's in there if you would like to take a look at it in the notes. Okay, I had a couple more things in this presentation, but because of time, I think I'm only going to talk about one more. And if you want to download the presentation, you'll get a little bit on optimistic locking. We could probably do a whole presentation on that, and maybe we will be later in the year before we come back to that probably. But one more thing I wanted to look at is the append option for HighPerformance Insert. This is like, you know, in the situation where you have, you're inserting a lot and the performance of the insert is critical, and maybe the performance of select is somewhat less critical. Okay, so this is a DBA thing they're going to put on the table. They're going to create a table just like they always do, or alter. Down at the very bottom, it shows an example of an alter. And they're just using the keyword append yes. What this means is when you insert to this table, the inserts are all just going to go pile up at the end. Normal behavior for DB2 tries to place the rows in their ideal spot within the table space according to a clustering index that the DBA has created. So there's a right sequence for the rows inside the table space as defined by the DBA, and by default DB2 is going to try and place any row that you insert into that location. And if it can't fit there, then it will look for space nearby on a nearby page, and if it can't fit there, then it's going to go to the end. This option just says, yeah, skip all of that, just put all the inserts at the end. And the insert algorithm is much more efficient this way. It's not having to look for space, it just is going to throw them all at the end. The price we pay for this is, of course, the rows not being placed where they belong. queries that were using the clustering index are going to suffer from performance because the rows that would normally be close together, that it's expecting to be close together, aren't actually close together, and that can result in some random I/O, additional random I/O for selects. But what you're saying here is I'm optimizing for the inserts. I want the inserts to run as fast as they can, put them at the end. If you're data sharing, you probably want to pair this with the member cluster attribute at the table space level, and that is giving each of the members of the data sharing group their own ranges of pages for those inserts, so that we're not going to get kind of global contention on those on a couple of pages right at the end. This is one of those things that you can use for high-speed insert applications. Okay. Again, I'm going to skip the last few slides on optimistic locking. I think they're a lot of fun, but we may make that the topic of another webinar. So I appreciate you being here today. I had one question in the window that I want to address. Somebody asked about the class that's coming up. If you download, so again, the link right here, themisinc.com/webinar. Somebody else commented that this link doesn't work. Yeah, this is just a display that you're seeing here. You might actually have to remember that and type it in, themisinc.com/webinars. When you go there, you will see a download link for this presentation. You can grab a copy of that. At the beginning of the presentation were links to the class that's being offered and a sign-up link for it. That is the optimization performance. dsimpson@themisinc.com is my email address, and I'd be happy to provide any details about what's in that class and how to sign up if you're having trouble finding it off the website. Okay, so thanks for being here today. Appreciate your attention. Feel free to email me with any additional questions as you start trying to use this stuff. And I hope you have a great rest of your lunch and rest of your day. Stay in touch. Hope to see you in upcoming classes soon.